All right, in this example, it says, find the area of the shaded region of the polar curve that's given to us by r is equal to 1 minus cosine 2 theta. All right, so let's see. This one's a little tricky. I only want to know one of them, right? So I need to know, it looks like it's going to be from 0, and it goes up here, swipes it out, and ends at pi. That's just kind of what I'm thinking. So to confirm that, I'm going to plug in, well, first I want to say area is equal to 1/2 the integral from alpha to beta. Alpha and beta are my angles, my thetas. And it's the r number, 1 minus cosine 2 theta squared d theta. All right, so let's see. Let's make sure we understand what's going on here. If I plug in 0 for theta, I get, 1 minus cosine of 0. Cosine of 0 is 1. So it'd be 1 minus 1, which is 0. So yeah, it looks like it's going to be 0. If I plugged in pi over 2, that's going to be 1 minus cosine of pi over 2 times 2. So that's going to be cosine of pi, right? Cosine of 2 times pi over 2, which would be cosine of pi. Cosine of pi is -1. So this is 1 minus a -1, which is 2. So yeah, up there, it's at 2. So nothing crazy is happening. It's just doing this. So if I sweep out 0 to pi over 2, that would give me half of it. And I could use some symmetry. A lot of the times we're going to try to use symmetry as much as possible to help us out. So I could set up, it'd be 1/2 of the integral from 0 to pi over 2 of that radius squared d theta. And whatever I get, I just multiply by 2. That would be one option. But I'm just going to keep going with the way I did it earlier. Okay, if I keep going, these angles give me those radiuses. I'm going to confirm of what I'm thinking is that at pi, I should get 0 again. So it'd be 1 minus cosine of 0, which is 1. 1 minus 1 is 0. So yeah, I'm pretty sure as we have more thetas, my graph is kind of looking like this. And then it would start looking like this. And then it's going to repeat. All right, so what are we doing? So I'm going to say the area is equal to 1/2 the integral from 0 to pi of 1 minus cosine 2 theta squared d theta. Plug in this into my calculator, I would get 2.356. Now, if it asked me to find the area and I had the whole shaded region, I could do this same thing right here and just whatever I get, multiply it by 2. So keep that in mind. Anytime you can use symmetry, find one region and then double it or triple it. Do what you need to do since it's symmetrical. Okay. Other way to do it is I'm going to look at this. I'm going to find out when is r 0, because it looks like right here it's 0. It starts at 0, then it gets bigger, and then it comes back to 0. So I'm going to say 0 is equal to 1 minus cosine of 2 theta. So solving this, I would get cosine of 2 theta is equal to 1. Where is cosine of theta equal to 1? So I'm just going to say, okay, cosine 2 theta, I'll take care of that 2 in a second. But where is that theta, which we're going to call it 2 theta this time? Where is cosine equal to 1? Cosine is equal to 1 at 0, and it's equal to 1 at 2 pi, and it's equal to 1 at 4 pi. It's only equal to 1 on the unit circle for that first point, right? 1, 0. And then 6 pi, on and on and on. So if I divide by 2, I get theta is just equal to 0, pi, 2 pi, 3 pi. So those first two is just going to be 0 to pi. So it's going to be 0, then to pi, and then it'll go back, and then keep going. Okay. So that's the other way. All right, let's go ahead and do number 3 while we're at it. All right, find the area of the inner loop of the limicon r is equal to 2 cosine of theta plus 1. This one's tough. All right, I wanted to find just the inner loop of that right there. Just that area. All right, so this is where I'm going to really try to build my intuition and think, what are the thetas that would sweep that part out? So I'm going to start, I'm going to say, okay, the area is equal to 1/2 the integral from alpha to beta of the radius that's defined to be 2 cosine theta plus 1 squared d theta. Hard part is finding those limits of integration. All right, so if theta is 0, in this case, I plug in 2 cosine of 0 plus 1. All right, cosine of 0 is 1 times 2 is 2 plus 1 is 3. So that radius is 3. So when time is 0, or the theta is 0, I get that point right there. All right, so that's my first point. Like, so first theta, there's the point. All right, so let's plug in pi over 6. So 2 cosine of pi over 6 plus 1. Okay, cosine of pi over 6 is root 3 over 2, but times 2 is root 3. So root 3 plus 1, what is that? Square root of 3 plus 1, it's like 2.7. So if I think about that, could go out about 30 degrees, that distance, the radius, the r, is 2.7. Okay, that's helping me understand right now it's sweeping out this big area, all of this. So if I just integrated from 0 to pi over 6, it would give me that area of that nasty thing that I just drew. Okay, so it looks like this, that sector. But that's not what I want, right? But as I keep going on, I'm adding up all those infinite number of sectors, and it's looking like it's doing that. I would get that part. What I'm trying to do is find this inner loop. All right, so we're still not there. Okay, let's plug in pi over 4. So 2 cosine of pi over 4 plus 1. Cosine of pi over 4, what is that? Root 2 over 2 times 2, so root 2. Root 2 plus 1. Okay, so some number. Okay, let's see. If I plug in pi over 2, it should give me that point right there. So I should get 1. So 2 cosine of pi over 2 plus 1. Cosine of pi over 2 is 0 plus, okay, so 1. So yeah, there it is. It's 1. All right, so when is it radius 0? We're trying to find the radius 0 again. So it's coming out, and now it's starting to get smaller. So as I go this way, where is it 0? Well, I know these thetas over here. This is 2 pi over 3 theta. This is 3 pi over 4 theta. This is 5 pi over 6 theta. Is it just, I wonder if it's just at pi. So I'm going to skip over these for a second. Trying to build some intuition, trying to figure out what's happening here. And then pi. So if I plug in pi, I'm thinking maybe it's 0. So that's cosine, all right, sorry, 2 cosine of pi plus 1. Okay, but cosine of pi is negative 1 times 2 is negative 2 plus 1 is negative 1. All right, so what this is telling me is, as I went over those, it's going this way. At some point it was 0, and then it goes like this, and when theta is 0 or pi, the radius is, since it's negative 1, it's back here. So instead of being positive 1 and being that one, it's negative 1, and it gives me that dot. So the way these points are going, it starts here and they're going along, and then somewhere it's 0, and then at pi it gets there. So from 0 to pi, this thing is doing that. All right, so I need to find out when is that R number 0. We're doing that again. So I'm going to say, okay, it's going to be one of these, right? So I could be guessing and checking, or I could set this equal to, this is my R number. I want to see when is that 0. So subtract 1, divide by 2. When is theta equal to negative, or when is cosine equal to negative 1/2? Well, that's when theta is 5 pi over 6, right? Is that right? Negative 1/2? Oh, wait, no. That doesn't seem right. That's the first one passed, so that would be when theta is equal to 2 pi over 3. And then it's also equal to negative 1/2 whenever theta is 4 pi over 3. And then again, so when it goes around again, but we're just going to look at those two. So when theta is 2 pi over 3, we get radius 0. So that's when it's here. And then it comes around this way, and then it's going to be 0 again at 4 pi over 3. And then it starts to sweep out this part. So my limits of integration are going to be these thetas right here when r is 0. Because we know as it goes, it starts at 0, and then at 2 pi over 3, it's right there. Then at pi, it's right there. And then back to 4 pi over 3, it's there. And then it would continue on to 2 pi. All right, so my limits of integration, that's the tricky part again. It's going to be the area is equal to 1/2 the limit from, or the integral from 2 pi over 3, 4 pi over 3. The radius is 2 cosine of theta plus 1 squared d theta. Plug that into my calculator and I get 0.544. All right, so the other thing I wanted to draw here is some people can see this, like when this was when theta was equal to 2 pi over 3, the radius was 0. And when theta is 4 pi over 3, the r is 0. When theta was equal to pi, the radius was negative 1. That's why it was back there. So yeah, that would give me this area right here. I could have also done, you can use that idea behind symmetry. Area is 1/2 the integral from 2 pi over 3 to pi, because that would just give us this part right here. And then of the radius squared. And then whatever I get, multiply that by 2. Use that symmetry. All right, hopefully this is helping. Thank you for watching the video. And if you have any questions, make sure you ask next time I see you in class. Bye.